Example 1.3 gives us three sets. Each one of the sets has three elements, so these would be known as finite sets. And we're being asked to describe each set. So the first statement says A union with C. So the union, by definition, is wanting to take all of the elements from A and all of the elements from C, and it wants to put them together as one big set. Now, if there are any elements that are shared in common, we do not need to write them down more than once. So we're only looking for unique entries of the elements. So A union C is going to be equivalent to the set 1, 2, 3, 4, and 5. So notice that we started with two finite sets, and the result was another finite set. Let's take a look at part B. It says A is going to be intersected with B. So by definition, the intersection is looking for which elements do we have in common between these two sets. So as I look at set A and I look at set B, I only see one element that they share in common, and that's going to be 3. So this A intersected with B is equivalent to this set with only the element 3 in it, which is still a finite set, just has one element. Part C gives us 3 sets, and it gives us 2 operations. Now this would be analogous to what you have seen in the real number world. So for example, if we had 5 plus 3, that example should look familiar, and let's say I wanted to subtract 7. Now the order of operations would prescribe to us work this from left to right. Start with the 5 plus 3, get an answer, then subtract 7. But if I wanted you to do the operations in a different order, the only way that I could force you to do that was by putting a grouping symbol. And parentheses is one of the most common grouping symbols that we use. And this would require me to then take the subtraction operation first, 3 minus 7, which would give me -4. Then I'll take 5 and add -4 to get to +1. So the analogy is very similar. We started with 3 real numbers and 2 operations. And then on the next line, we were able to get down to 2 real numbers with only 1 operation left. And then finally on the last line, all we're left with is just 1 real number. A single real number. Happens to be the value 1, but it's just a single real number there. So the same idea is going to apply when we're looking at sets. So looking at A intersected with B, union with C, I have to go with what's in the parentheses, that grouping symbol first. So on the previous part B, we found that A intersected with B was equivalent to 3. So I'm going to take that set of only one element, 3, and I need to union it with C now. So I take a look at C, which has 1, 2, and 4, and with the union, I'm just going to dump 1, 2, and 4 along with 3. So the result is going to end up being 1, 2, 3, and 4. And for those that like to box things in, this would be the final answer that you would box in there. So this one took multiple steps because we had multiple operations. Let's take a look at part D. We have another grouping symbol. We're dealing with B intersected with C first. So looking at B intersect with C, let me erase what we have here. What do these two sets share in common? I see they each have a 2, as well as each having a 4. So B intersected with C is equivalent to the set with 2 elements, and those elements are 2 and 4, but I have to intersect that with set A. So looking at set A, I'm going to do this all over again. Let me erase. So set A, when I compare that with 2 and 4, I don't see anything that they share in common, which means I must be having a empty set. There is absolutely nothing that these elements share in common, that these sets share in common, so therefore there's no elements to consider. We call that the empty set.